So the portable carrier hardware. So we have displays, we have dual scan, passive matrix, or active matrix. So the matrix itself can be active or passive depending on how the display is built. So if it's an active matrix, the screen will open and close and let the light through to make the images. If it's a passive matrix, it just sits there and the light does the controlling. So they have different ways that they built those. The processors, the tape carrier package. The tape carrier package is designed for small spaces. So we're talking about reduced, palm tops, laptops, very small laptops like your netbooks and Chromebooks. So they had a package called a tape carrier package, and what that is where they shrunk the chip down, and the leads come off at a small angle, which they call the pitch. Instead of coming straight down and then being mounted to the circuit board like this, they come down like this so that you can see the amount of space that the board's going to take is less. So that's what the tape carrier package is about. So it's specifically looking at lead density, so the number of leads that are around the edge of the chip. They still need all of those connections, the electrical connections, and they need the chip to be very close to the motherboard. And I think they were 3-layer. And the voltage reduction, so they use less power, which means they operate slower, so they're not consuming as much electricity, and therefore the battery will last longer, so you can have a smaller battery. And then with respect to memory, they use the same type of dynamic RAM and static RAM as desktops do. Hard disk drives, we had enhanced integrated drives in most portables, but they have the smaller factor one, the 3.5-inch drive. They have removable media, so they have a hot swap bay for memory cards and things like that, like SD cards. They had a keyboard, they had an integrated into the unit, which makes repair difficult. So you couldn't actually remove it. You had to change the whole component that the keyboard was mounted to on some of them. And then they also come with pointing devices. They have the trackball, the track point, or the trackpad. So they'll have a little ball that you can spin, a little round ball that sits on there, or a track point where it's a little J-mouse where you drive it with your finger like that, or a trackpad, which is just a little square pad, like what you're used to seeing today. And USB ports, they make it easier to add new devices to portables. The hot swap capability supports printers, scanners, and other products. And they also had a PCMCIA USB card, and that also supports older portables. So that's pretty much it for those. They had different types of batteries. The nickel-cad batteries are the oldest technology. They had some issues where they had memory problems. So if you didn't charge them, you didn't wear the battery down and charge it all the way, wear the battery down and charge it all the way. If you would just wear it down halfway and recharge it, halfway and recharge it, halfway and recharge it, now when you ran it down, it would only charge halfway. It would never recharge fully. So that was a problem with those batteries. So what happened inevitably is you could always only charge it less and less and less and less until it would no longer work at all. Then you had the nickel metal hydroxide batteries, which are used in low-end systems. They don't last very long. And then we had the Li, which is a lithium-ion batteries. They last longer and are used in higher-end systems, and that's what we use today. And then the lithium polymer, which is the newer ones. So the lithium-ion is still used in some today. They also had some memory problems, but not as bad as the nickel-cadmium. And the lithium polymer is the newest technology and increases battery life and decreases the weight. So they operate pretty much the same as the lithium ion, but they're lighter. They're not as heavy, not as dense. And then proper battery disposal is important, and you don't want to mess with those batteries. The lithium ion are very powerful, and they can blow up if you mistreat them or burn them in a fire or something like that. They're very dangerous, very powerful. With respect to power management, we have suspend mode, hibernate mode, advanced power management standards, and advanced configuration and power interface standards. So we had the ACPI. This is pretty much the same thing you'll find in a desktop. It's even more important. You'll probably use it less in a desktop than you would in the portables because they need to make sure that they have enough, they stretch that battery life. So this became very important and to understand how to configure it in the OS for these little devices. And in summary, portable computers include laptops, notebooks, and sub-notebooks like palm tops, specifically, that's what we've been talking about here, the really smaller ones. And they have different types of PC cards that provide support for a variety of functions. We talked about the substrate layers, the multiple layers inside the boards that we don't want to flex them. And display screens for portables are either dual scan or active matrix. And the USB ports make it possible to hot swap different USB devices. And power management has 2 modes, suspend and hibernate.